Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Now that we have a basic understanding of chain rule, it's important to know that it rarely happens in isolation. It often is used in conjunction with other rules, such as the product rule and the quotient rule. Now, before we get started, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. In our first example, the equation for y, we can see that it is a product of x cubed and e to the power of 2x. However, e to the power of 2x is also a composite function. So how do we differentiate something like this? What you should recognize is that the dominant operation here is multiplication, because we have this function multiplied by this function. And then within this second function, we have a composite function. So this means we're going to be applying our product rule first, which means y prime is equal to the derivative of the first function, so that would be x cubed prime, multiplied by our second function, which is e to the power of 2x. And then we're going to add our first function, which is x cubed, multiplied by the derivative of our second function. And now the derivative of x cubed is 3x squared. And then we multiply that by e to the power of 2x plus x cubed. And the derivative of e to the power of 2x is going to require chain rule. So the derivative of the outside function, well, that's still just e to the power of 2x, but we need to multiply this by the derivative of 2x, which is 2. So therefore, we get 3x squared e to the power of 2x plus 2x cubed e to the power of 2x. And if you want, you can factor out a common factor of x squared e to the power of 2x. And we're left with 3 plus 2x. So this will be our y prime. Now for our second example, we are going to look at a problem that combines the quotient rule and the chain rule. Again, notice that the dominant operation here is division. And then within our denominator, we have a chain rule. So therefore, to find f prime, we're going to be applying our quotient rule, which means we are going to take the derivative of the numerator. So the derivative of ln of x is 1 over x. Multiply that by our denominator without doing anything to it. And then we're going to subtract our numerator, which is ln of x. And we're going to multiply this by the derivative of the denominator. Now, the outside function of the denominator is something squared, which means it's going to be 2 times that something, which is 2x plus 1 to the power of 1. And then we need to multiply this by the derivative of the inside function, so the derivative of 2x plus 1. And the derivative of that is just 2. And now, to finish off the quotient rule, we need to divide this by our denominator squared, which means we get 2x plus 1 to the power of 4. In this one, we can't really simplify much further other than to factor out a 2x plus 1 from both of the terms on top. And if we do that, we get 1 over x times 2x plus 1 minus 4 times ln of x. And then our denominator is going to be 2x plus 1 to the power of 4. And now we can go ahead and cancel out a factor of 2x plus 1 on the top and on the bottom, which means our final answer is going to be 1 over x times 2x plus 1 minus 4 times ln of x, and this is going to be over 2x plus 1 to the power of 3. And since there's no more meaningful simplification here to be done, we can just leave it like this. The important part of this is as long as you're able to identify the chain rule inside of the quotient rule or the product rule, then you're on the right track. There's no need to worry too much about simplifying the expression afterwards. And now let's go ahead and take a look at our next example, which is an AP style problem that involves interpreting given points. So here, we're not given the specific composite function. We're just told that h is a composite function. It's f of g of x. And then we're given some values for g of 1, g prime of 1, f of 2, and f prime of 2. And the question is asking us to find h prime of 1. So in order to find h prime of 1, we need to find h prime of x first, because once we find h prime of x, we just need to go ahead and substitute x is equal to 1 into that expression. So since h of x is equal to f of g of x, h prime of x is going to be equal to f prime of g of x multiplied by g prime of x. And this is the chain rule. So now that we have an expression for h prime of x, let's go ahead and substitute x is equal to 1 into here and see what happens. H prime of 1 is going to be equal to f prime of g of 1 multiplied by g prime of 1. And now let's take a look at what values we have. So g prime of 1, we're given that it's equal to 3. And then g of 1 is equal to 2. So let's go ahead and substitute those values in. So we get this right here is equal to 2, and this right here is equal to 3, which means we have h prime of 1 is equal to f prime of 2 multiplied by 3. But we're also given what f prime of 2 is. We're told that f prime of 2 is equal to 4. So if we go ahead and substitute that value in, we end up with h prime of 1 is equal to 4 times 3, which is equal to 12. And now we're going to move on to the last problem of this video. And this one is an IB style problem requiring understanding of content and interpreting skills. Please take some time to read and understand what this question is asking for before continuing on with this video. All right, are you ready? Let's continue. Part A, we're asked to write down the value of f prime of 3. So what they're testing here is whether or not you understand the relationship between the derivative of f at 3 and the tangent line to the graph of f at 3. So recall that the tangent line to the graph of f at 3 has the same slope as the graph at that particular value. And we find the slope by taking the derivative. So therefore, the slope of the tangent line at x is equal to 3 is f prime of 3, which means because our tangent line has a slope of -2, that means f prime of 3 here is equal to -2. Now part B is asking us to find f of 3. And similar to part A, this tests whether or not you know the relationship between the tangent line and the graph at a particular point. And in this case, the tangent line and the function share the same point at x is equal to 3. So this means f of 3 is equal to -2 times 3 plus 10, which is equal to 4. Now part C is asking us to find h of 3. So we're given that h is f of g of x, where g of x is equal to x squared minus 2x. So this means h of 3 is going to be equal to f of g of 3. But since we're given the specific function for g of x, we just need to substitute 3 into our function g, which means this is equal to f of 3 squared minus 2 times 3. And that evaluates to 3, which means we're looking for f of 3. And this was just the answer in part B, because we found out that f of 3 is equal to 4. So therefore, h of 3 is equal to 4. And now the last part is asking us to find the equation of the tangent line to the graph of h at x is equal to 3. And we've done this multiple times already. In order to find the equation of the tangent line, we need a point and we need the slope. So the point we already have, because part C told us that h of 3 is equal to 4. So therefore, the point is 3, 4. And now to find the slope, we need to first find h prime of x. So h prime of x is going to be equal to f prime of g of x multiplied by g prime of x. Substituting in our x value of 3 means we're looking for h prime of 3. So that's going to be f prime of g of 3 multiplied by g prime of 3. We found g of 3 earlier in part C. This was g of 3, and g of 3 evaluated to 3. So therefore, this here is going to be f prime of 3. And now, g prime of 3 is something that we need to go ahead and find. So let's scroll back up a little bit and see what g of x is. So g of x here is x squared minus 2, which means on the side, let's go ahead and find g prime of x. Now, g prime of x is going to be equal to 2x minus 2, which means g prime of 3 is going to be 2 times 3 minus 2, which is equal to 4. So let's come back here and put that in. So g prime of 3 is equal to 4. And now the last part is f prime of 3, but we found that in part A. F prime of 3 is equal to negative 2. So therefore, h prime of 3 is equal to negative 2 times 4, and that is going to give us a value of negative 8. So now we have found that h prime of 3 is equal to negative 8, which means the slope at that particular point is m is equal to negative 8. And now we're ready to go ahead and write down the equation of the tangent line to the graph of h at x is equal to 3. Using our point slope form, we get y minus 4 is equal to negative 8 times x minus 3. And this is the equation of our tangent line. And now let's do a quick recap of what we covered in this video. We learned that chain rule rarely happens in isolation. Usually it's mixed with product or quotient rule. And when faced with a problem like that, we need to identify what the dominant rule is first. Meaning, what is the LSI function? Do we have chain rule inside a product rule, or do we have a product rule inside of a chain rule? And you always work from outside inwards. Then we looked at a couple of AP and IB style problems. On some AP and IB exams, you often won't have an equation. You must apply the chain rule using coordinate values from a table. And lastly, connecting our chain rule to the tangent line problem, remember that using the chain rule only helps you to find the derivative, which gives you the slope m. But in order to find the equation of the tangent line, you still need a point, which means you need the y-coordinate by substituting the x value into the original composite function. And now it is your turn to give this a try. Can you find the solution to the problem on the screen here? Make sure to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.